Hey folks, Quilly18 here, and welcome to another Unity 3D multiplayer first-person shooter tutorial. Now, in the last one, we added in a cool soldier character model that we found from on Mixamo.com. Now what I'm going to do is add a couple of animations. That's all we're going to do. We're just because of time, because of skill, because of all kinds of things, we're only going to throw in a couple of animations. Now, if on the Unity 3D official site, there is a tutorial for Mechanim, and that includes a bunch of animations and different things like that. So what I've done is I just downloaded that one example scene that they have provided for us and grabbed a couple of the animation files out of there, idles and runs. Now these are actually full characters that are like, there's a full character model in there. I could drop this in the world and zoom in on it, and you know, there's that guy there, and then another copy of that guy there. But inside each one of these files, there's a single animation. There's a couple of different ways that you can package things up. It's not particularly important, but there is animations in here. Now, this rig, why is this not a humanoid rig? That's kind of odd. Let's go and apply that. Actually, what I should do is use the same avatar as my other one. It doesn't matter. Let's ignore that. So I'm going to make sure these are both set to humanoid just because of the way they've been imported. Everything should work fine. I can double check that everything is set up fine for them. Everything looks groovy over there. Everything is green. If I go to muscles and then zoom in, we can see that everything is fine. Although this is mostly a skinning test than anything else. We don't actually care about the model itself. What we're interested in are the animations that are in this model file. So the one that's called runs has run, run right, run left. And if I open up the preview over here and bring that up and then hit play on run, you can see this model doing the run animation there. It's not set up quite right. We're gonna have to make some adjustments there. But you might think, okay, well, sure, this animation works for this guy, but what about our guy? Well, all we have to do is find our model over here. So we're gonna grab our soldier and just drag that into this window here. And now the same animation is gonna be playing out with our soldier instead. Groovy? Groovy. All right, so a couple of things. This animation here is not looping properly. It's got a weird stutter and it's not necessarily the same. So why is that? It's because this animation that was pulled in, it's sort of giving us the entire range of the animation, but we don't necessarily want the entirety of the range. There's sort of a sweet spot at the start and end of this animation cycle. So let's advance it a little bit. Let's bring it to the point where it looks like, yeah, see right here, his right foot is touching the ground. So let's say, like, what if that were the start? Yeah, right here, as the right foot touches down, we'll call that the start. Now for the finish, we're gonna finish it when the right foot touches the ground again. So follow the right foot, follow the right foot, follow the right foot, and it looks like it's just about touching down now. Actually, the scene, the frame before is actually better. And do you notice in the inspector window, like I was staring at the preview at the bottom, but look at the loop match lights over here. Watch these as I sort of jiggle it back and forth. Here it's yellow, here it's green. And even the graph, there's certain peaks at the ideal looping time. It has figured out, Unity, the Mechanim system in Unity has automatically figured out for us, this is probably the right place to put the loop in there for us. Okay, so that sounds good. We'll put a cut in there. Now if we play that, oh, that's looking a little better. Now, it is supposed to be a loop, so let's turn on the loop time for this. Now it's a nice, smooth animation. All right, that's good. I like that. Right, and again, we took the animation from a separate file, but it's working here. Now, this is supposed to be running forward. If we watch this guy, and let's go and apply these changes and then just sort of click out and click back in here. I want this to reset. Did it reset? Yeah, okay. So right now, our person starts at the center of the cross of these two thick lines. Hopefully the resolution is decent enough on the YouTube. That's how my dad says it, YouTube. All right, so we do this, right? He's starting at this cross here. Now he's supposed to be running directly forward. So ideally he should be continuing directly along this line, right? So let's hit play and see what happens. Oh, he's not. He's clearly drifting in one direction and then sort of drifting back. What is going on? He's not going in a straight line. Well, there's a few things, and it mostly comes down to, if we go down here and you see the average velocity, he's moving forward. It's mostly in the Z direction, so that's a good positive number. That's good. But then there's slight movement in the X and Y, which is not, that's really weird. So one of the things we want to do is we probably want to bake in the the transforms on the root, both the rotation and the Y position. And to be honest, I can't tell you 100% exactly what this does, except it makes things work better. So first of all, if we bake those in, we'll apply again because I think it'll mostly reset the preview. So now, first of all, the motion is vaguely smoother, but we're still drifting off. One of the big things, the arrow's not swaying quite as crazily as it is before. And basically, we sort of normalized some of the things with the root movement, but we're still drifting. But we can fix that, sir. We're still, now our Y is properly 0, which is good. That's exactly what we want. We shouldn't be like drifting off into space as we do this walk, but we're still drifting to one side. And this the rotation transform, we can put an offset in here. If we sort of jiggle around with the mouse and look at the average velocity, we can clearly see as we drift off in this direction, we can get this to be just about 0. I try to get it as close as possible to 0, and then what I usually do is just manually change the number. There we go. To be 0 in the Y speed. So let's apply this one more time and then hit play. And now our person should follow this line perfectly. He's running in a completely straight line, which is exactly what we're looking for our run animation. And again, because I'm mostly lazy, I'm going to mostly just use that. Now, I did discuss last time, there are 2 different ways to handle movement in the world. One is to use the mechanism system, so derived from the actual animation, and one is to use script-based movement. For this game, I really am tempted to do the mechanism thing, but the problem is we don't have enough animations for that. For those sorts of animations, you really need everything. You need the proper sidestep animation, all sorts of different things. What we're going to do is we are going to use the mechanism system. We're going to use the mechanism flowchart, but we won't actually use this root transformation to determine our movement. We will still use our script to change our X and Z position in the world. So this running, it won't match. Like this actual, like our footsteps won't actually match our true speed in the world. Well, we could do it for the forward velocity. As long as we moved at a speed of 5.354 in the Z, then when we run forward, actually everything will be perfectly fine. The thing is, I'm going to use this exact same animation when we're moving in any direction whatsoever, so then it's not going to really work. Because unfortunately, the Unity mechanism tutorial does not offer all those animations. It's got a few more. It does have the idle, which we're going to check in a second. And then it's got sort of like running and turning at the same time, but it doesn't have sidestepping, which is no good. And their jump animation is not really appropriate for what we're looking for either. It's that sort of like jump, like do a shoulder roll. It's very realistic kind of jumping, but who wants realism? It's not that kind of game. This is Unreal Tournament that we're cloning here. This is not a modern military shooter. Good God. Who wants anything like that? Those things will never sell. Right, that's animation number 1. Animation number 2, if we go and check it out, animations, and idle, and it does remember our character there. So the idle animation is just standing there, a slight sway from leg to leg, and I think he'll look a little bit to the side. Oh, sniffles a little. And again, this is the animation that was taken from the mechanism tutorial from Unity 3D, but it'll work with our character perfectly fine. And there's not really any adjustments to do with that. I mean, it's just a guy standing still, so who cares, right? Good. So, all right, let's find our character. So on our character, which is here, we're actually going to get rid of all the old animation stuff. We're not going to use any of that at this point. I'm actually going to get, or not the animation, the actual movement stuff. This character controller, well, we actually have to delete it from the bottom up. The character motor, removed. Oh, it did have more. That's what I thought. Okay. FPS controller, gone. Character motor, gone. And the character controller, gone. Oh, and the mouse look script is going to be gone. Where is it? Actually, mouse look might be fine. Mouse look is only responsible for rotating us as we move the mouse. So if I launched this right now, actually it might whine because the photon view is not observing anything. It's observing a component that no longer exists. Yeah, which is what it's freaking out about here. If I just throw in, say, the transformation, the transform there. So we're sort of kind of stepping backwards from where we were. So it's very common. We're going to break things before it works again. Oh God, what else have I done? Prefab lost its way. Lost its way out of its asset file? Save your scene. Next time you launch the editor, it'll be gone. What is it saying? Oh. Well, a few things. One, in our network manager, we are trying to enable or disable scripts that no longer exist. Come on, open my, yeah, I don't know why mono-develop wasn't opening. All right, so we're going to disable the FPS controller and the character motor script. The mouse look script can actually still be there. That should be fine. I don't know if that was the only error that was going on. Yeah, there we go. So we can still look around. We can no longer move, which is okay. And if I grab our player controller and move in here, there, our character is there. And our character can look around. You can see the camera is panning all over the place. All right, so that is fine. We can keep that in there, no problem. So that is step number one, is removing the old scripts. Step number two, we are going to add an animator component. Oops, not a new script. Animator, right here. So it needs to know a few things. It needs to know what avatar to use. Now, the avatar was automatically created when we set the rigging. Remember on our model import, we set the rigging rules. We said humanoid and create a new avatar from this model. So that's our soldier avatar. Yeah, soldier avatar. These other avatars are from some other models that were created there. So soldier avatar is what we're going to choose as the avatar. And it needs a controller. It needs a runtime animator controller. We have none. So what do we do about that? Well, we're going to go and create one. Do I put it under animations maybe? Sure, doesn't really matter where we put it. Create new animator controller. We're going to call this player anim controller. And actually, I'll put a capital P in there. Good. So let's go back to our character. It's our animator here, and now we've got a player anim controller. Lovely. So what the heck is the player animator controller? If sorry, went a little too fast there. In my player guy here, if I double click on this, or I double click on this, either one, it's exactly the same, it will open up this, I don't know, this finite state machine view is basically what this is. You can pan around with your middle mouse button. You can box select. Right mouse button doesn't do anything if you click and drag. If you just right click, it pops open menus. Here's where we control what our character animation transitions look like, how we go from one animation to another, for example. In our case, it's going to be extremely simple because we're going to basically just have two animations. We're going to have idle and we're going to have run, and that's all. We can ignore this any state. Maybe we'll talk about it in some future thing, but this is not going to be an all encompassing Mechanim tutorial in any way whatsoever. So we are going to have two animations in here. So these are the animations. Well, this is the FBX, which has a model, but also if we scroll down right here, we can actually see the actual animation. So I'm going to grab this and drop this in to my animator controller. And I'm going to do the same thing for runs. Right, there was actually three animations in this file: run right, run, and run left. And we're not using the run right, but you can watch it, and this is sort of like running in a circle. But we're not going to use that. We're just going to use this run, which is the one we adjusted before, and everything is awesome on. So we're going to drop that into it. First thing you might notice is that idle and run are in different colors. The reason that is, the first animation you drop in is considered to be the default animation. So it's automatically set to idle here. I could right click on run and make this the default. And, you know, for the sake of argument, I'm going to go ahead and leave that in there, hit play. Then I'm going to go to the scene view, find my character. Oh, there he is. He's running. He's actually just run off into space. But clearly, the run animation is the default because that's what he's doing. If I stop this, right-click on idle, set as default, hit play again, go to the scene view, go to my character, hit F to focus on him. There we go. Now he is sitting in the idle position. He's going to do the wiping his nose and all that kind of nonsense. Okay, so great. This is awesome. It's worth talking about why, when the run animation was going, once again, why he actually literally ran off into space. Right? And that's because, as I said, there's two ways to handle the animation. Two ways to handle the actual movement. One is to move your character in a script by changing the transform.position. and one is to use the mechanism built-in way. And by default, when you set up an animator on a character, right over here, an animator, it will use that. This is the apply root motion. If I turn this off, okay, we're going to put run to be the default again. We're going to hit play one more time. Now, I go to scene, player controller, hit F to focus. Now, he's just running in place. Oh, there's a slight jitter to the animation, which I didn't realize, but I'm not going to stress out about it. Now he's running in place. The reason is that the root motion is no longer being applied to his actual XYZ coordinates in the world. It's expecting that we'll use a script to do it. If I toggle this, he'll start moving, turn it off, turn it off, right? Kind of fun to do, actually. What does animate physics does? I believe... Let me make sure I'm not lying to you guys here, but I'm pretty sure what it means is that when he runs around, if he happens to run in, his mechanism-based motion, if he happens to run into, say, like a crate, a box that is physics-enabled, it's got a rigid body component, for example, it will bump into the box and actually knock it out of the way, for instance. Now, I'm going to avoid some of those actual real-time proper physics in here because synchronizing physics over the network, like rigid body physics and collisions over the network, is actually kind of wacky and wonky. We may look into it one day, but I'm going to tell you right off the bat, stay away from it unless you absolutely positively, like, you're making a game based on having physics run over the network. And if so, be prepared to have to write a lot of special code to deal with that kind of nonsense because rigid body mechanics don't really synchronize over the network in any sort of automatic way. You've got to work for it. So that's what that second bit does, unless I'm mistaken, in which case I'm lying to you and, deal with it. Anyway, so in our example here, we could actually go either way in terms of the applying root motion or not. If we had the full proper set of animations, we could do apply root motion. And then we'd end up with a game, and most more modern first-person, well, it's not even about first-person shooter games. Most modern games that involve humanoid characters running around and where the animation really looks good, their feet positioning works properly, they're not slipping and sliding, maybe they're grabbing, ledges and pulling themselves up. We'll use root motion plus some other scripting mechanics in there. We are going to keep it a little bit more old school for simplicity. We're going to leave that off, and we're just going to move ourselves via scripts. Now, it is possible to do the networking with this just fine. So in a single player, it's great because the animation just runs the run. But how does the network know where you're supposed to be? Yeah, you can do the thing where we just observe the transform directly, which works okay. But how do you sync the animations and different things? And the way I will do it, I'll just give you a quick rundown. Okay, I'm going a bit on a tangent, so if it's going to confuse you, just skip ahead a little bit. But we're still going to do this thing where we send the real position and real rotation. But then we're also going to do something like, actually, you know what? I am going too far ahead. We'll come back to this. We're going to switch the idle back to the default because that makes sense. We're going to be in the idle state until we start moving, in which case we're going to do the run. So the way we move from one to the other is we create a transition. Right-click on idle, click Make Transition, and move it to run. Okay? So now we've got this transition here. So it can go from idle to run. And actually, by default, it just uses this exit condition based on time. After the idle animation is played through 99% of itself, it will transition over to a run. That's just the default. Obviously, that makes no sense. We want to move to a run when we're actually running. In other words, when our speed goes above 0 is usually when we want to translate to a run. So how do we do that? Well, you may have noticed this little parameters thing over here. And what this does is define a set of parameters that are used in this animation. So, for example, we could set a float, called speed. And then, now that we've got that, in our conditions for our transition, so again, here I'm clicking on idle, here I'm clicking on run, right? Idle, run, idle, run. But I can click on the arrow, which is the transition between the two. And then from this pull-down menu, now from the conditions, I've got speed. And I can say when the speed is greater than 0.1, transition from idle to run. And I can actually test that right now. If I hit play, same thing. Oops, you know what? I can't throw myself off the cliff. Never mind. And then zoom into my character. So right now, I am floating above the ground just because we're not properly running the physics yet, but that's okay. So we've got our character, and he's currently in idle. And I can manually change the speed. I'm going to change the speed to 1, and now he's going to go into the run state. And apparently, I'd left the root motion thing on, which I don't want. But you can see when our speed parameter changes to, well, anything above 0.1, it will translate or transition to run. And then we want to do another transition back. So right-click on Run, choose Make Transition, go to Idle, left-click, and then click on this transition. We're going to go to Exit Time, Speed is less than 0.1. As mentioned before, Unity does provide an excellent mechanism tutorial. If you want to get more in depth into that, you can go and check that out. Here we're going to try to keep it super simple and just focus on the actual shooter. There. Now we can translate back and forth from idle to run by changing the speed parameter. So what I'm going to do is I'm going to create a new movement script over here. And actually, we may try to decide how I actually want to do the movement in the world. Since I'm not using the mechanism system, oh, there is something I want to mention. Let's make let's set our speed parameter to 1, and we're going to hit play again here. And go into our scene, find our guy, and I'm going to turn on the apply root motion. Right? He's going to run, and he's going to run right off into space. Why is he just hanging into space? Well, obviously we don't have any actual physics coded in here, right? So with the pure built-in mechanism system, it's actually very easy to make our person respond to physics. We have to add a component. We need a rigid body, and we need a collider again. I did take off the character controller just to strip everything out again, but we will once again need a rigid body, and we can use a capsule collider for this as well. Let me put my person in the world so we can actually see it. Obviously the capsule collider is too low, so we're going to move it up to a 1. We're going to increase the height to 2 and probably make it skinnier. I think at 0.3, that looks pretty good. And we can make our person, say, realistically heavier, say 50 kilograms. Just as a ballpark, that's going to be fine. Now, if I just hit play on this, he'll actually fall over because we're using a capsule collider, not a character controller. So he can fall over. So what we want to do is freeze the rotation so that the physics engine won't topple over our capsule. We can still rotate our character just by like directly rotating through our animations. That's totally fine. But this should pretty much do that. So let's apply this to our prefab, delete this version of the character controller, hit play again, find our character in the game world. There he is. And now if we toggle on apply root motion, he should run off the cliff and fall down. Good. There you go. So that's how you can get your person to properly respond to physics if you're using the full mechanism system, which again, we are not. Okay, we are not going to use it for this simply because we lack the animations. If we had the animations, that's what I would be using. And anyway, there it is. If I was better at making animations in Blender, this is what we would be doing, but you guys have to deal with the fact that I'm terrible and I suck. So, all right, got rid of the controller, or sorry, got rid of the capsule collider and the rigid body because we're not using those. I will put in the character controller back in. The character controller is not part of the character controller package. The character controller package has scripts for moving. The character controller is built in. It's a component in the physics system called character controller. And it is basically, if I zoom in here, it is basically a capsule collider that can't fall over. It's very similar to what we just did. In fact, I could probably just leave in the capsule and the rigid body to a certain extent, although the character controller does have a few other advantages that we'll talk about shortly. But there we go. So I'm just bringing it up in the Y again. The height is correct. I'll bring down the radius. And actually, one of the tricks I always like to do is bring the Y, just give it that extra 0.1 just to avoid wonky rounding errors where it might fall through the ground. All right, so we're going to apply that. But now we're going to create our own movement script, which is something, again, before we were using the, well, we were using the standard character controller from that asset, that package, right? Character controller package included these character controllers here, which we were using the first person one. And it has scripts, right? It had the character motor, the FPS input, and all those scripts, which we're not using those, except we're still going to use the mouse look, although we really could reprogram that because it's super easy, but we'll use their mouse look. That's fine, right? Yeah, right here, mouse look. Good. So we're going to create a new one. So in player stuff, I'm going to make a new folder here. What's my time like? Good enough. Called scripts. And in there, I'm going to call it actually will still split. I'm going to take a lesson. No, I don't need that. We can have one script. We can call it player movement script. So on our player controller, we're going to add the player movement script. I'm going to apply this. And what I am going to do, though, is I'm going to still follow what I was doing before. I'm going to disable this by default. And then in my network manager script, I'm going to enable my, what did I call this? Player movement. So I'm going to find my player movement component and enable it for me. This is my player. The player that's connected to this local machine, I will be able to move it. Otherwise, the position of this character is simply going to be synchronized via the network character script. And I could, this network character script and this player movement script could actually be one file all put together. In fact, that's usually what I do, right? In this network character script, which is here, in my update, if is mine, I could do something like, well, if input dot get access or something, I can do all that stuff here. Maybe I should do it here. I literally think it makes no difference one way or another. I'm trying to think of what's simpler and more straightforward for you guys. I guess I'll just keep the player movement stuff isolated here. Keep in mind, this is only going to apply, I'll put a big note. Like this. This component is only enabled for my player, i.e. the character belonging to the local client machine. All right, clear enough, hopefully. We'll see. All right, player movement. We need to, basically we just need a float for speed. I'll just throw in a 10 in here. We'll make it public in a sec, but I always like to start it off private like this because I make my adjustments for my defaults in the script. And then once I'm happy with a reasonable default, then I'll make it public, and then you can fine tune things outside of that. The update, we'll do it real proper like. We'll have both an update and a fixed update. So what is the difference? You guys remember? Fixed update is called once per frame, exactly what it says on the tin. Whereas fixed update, updated is wrong, fixed update, is called once per physics loop. Do all movement and other physics stuff here. Right? That's the way it properly interacts with the physics system. And what we're going to do is in update, this is where we're actually going to read the inputs, and then we're going to apply the movement here in the fixed update. I like that. I think that's a good way of doing it. The network character doesn't do anything funny. No, good. All right, so in fixed update, so this is our actual, this is the speed of our character, but we'll do something like, we'll have a vector 3 called direction. Yeah, I like that. And we'll automatically default to this, but we'll make it explicit. This defaults to 0. Now in update, we're going to change direction to be equal to a new vector 3. The y component is definitely going to be set to 0 until we implement jumping, which will happen. The x will be input.getAxis, and it's going to be the horizontal axis on our keyboard. And then our z is going to be our backwards and forwards, so input.getAxis vertical. And what we're going to do is we're going to have this be normalized. And the reason for that is then, what does this mean? So let's assume I was hitting the up key, right? The up arrow and the right arrow. In which case my vector would have a 1, 0, 1 is what the vector would be. Now 1, 0, 1 is a vector that's got a length that is longer than the length of a vector that's just this, which would just be if I held the right arrow. Or maybe more accurately, something like this, which is just if I held the up arrow. What would mean is moving diagonally would actually cover more distance. Remember, like the you know, the hypotenuse, is equal to, well, technically h squared is equal to a, this is not a good environment to do this in, plus b squared, right? Anyway, it would mean that whenever we moved in a diagonal line, we would be moving faster than if we were moving in, a straight backwards or forward or left and right kind of line, which, depending on what kind of game you're doing, might be good. But here, by normalizing it, it means that if we're only hitting forward, then we end up with this, which will be a length of 1. And by being normalized, if we ended up with a 1, 0, 1, normalized ends up being what, like, I can't remember off the top of my head, but like 0.66, 0, 0.66, which this also has a length or a magnitude of 1. This autocomplete does not like this. Oh, I guess I should put it in a comment, then it would stop whining at me. Length of 1. The 0.66 is not right. I don't remember what the square root of 1 is, but it would mean that our speed is consistent even if we're going in wonky diagonals, right? So this is our desired direction, which we do in the update. Because the advantage of doing this way, it responds perfectly. It checks the input every single actual graphical frame, which is good. This is the resolution level you kind of want to be capturing input to properly make it responsive. Just trust me, that works really, really good. And then in fixed update, well, we have a character controller on our character. We don't want to grab it every update, though. We want to cache that. So character controller, so we'll call it CC. So CC equals get component, character controller, and then in our fixed update, we can do CC dot, we'll use simple move for now, right? Simple move simply wants a speed. So that is direction multiplied by speed, it's there. We could also use move, in which case we would also do a time dot delta time. The difference between the two, so because move wants an actual distance, whereas simple move just wants a speed, which is why for move, you've got to add the time dot delta time to get, the accurate amount of time that happens since the last frame. Simple move will also take care of gravity for us. We'll work with gravity a little bit when we get into jumping, but we're going to leave it just like this for now. And I promise, unlike the previous first-person shooter tutorial, I won't mess up and forget to reset the Y velocity, which was making our jumping really wonky. Or the jumping was fine. It was falling off things that was really wonky. Let's see. Is that all we need to move around? It may be. Let's give this a try. Let me make sure I've applied this. We can delete that. Hit play. Oh, we've got compiler errors. I'm also going to move my scene view back over here. Where are my compiler errors? Clear. I am missing a parentheses here. There we go. Wow, is that really the only, the only syntax error? Doesn't mean it's my only logic error. Now, looks like I still have my my run animation as my default. That's okay. We'll also get rid of this problem where we can see ourselves. Unless you want that. Maybe you're into that. We'll talk about different things there. Because in some games you can see your feet and some you can't. And there are different better ways of doing one way or another. But now if I hit forward... Oh! My axes aren't right. Or are they? Could just be my player's not oriented correctly. X and Y... Yeah, the X is on horizontal. Is my character coming in with the rotation? Let's see here. That might be what's going on. Oh, yeah, my character... Oh, right, because there's the mouse look. Oh, derp. I'm being silly. If I hit forward... There. See, I'm hitting forward now. Backwards. Left. Right. Everything is awesome. Except when I turn here and I hit forward, I'm still moving there. Because I'm not adjusting my direction. I'm applying this direction as sort of world coordinates. I want to modify my direction. This is where I want to go based on keyboard input, but I actually have to multiply this based on my rotation. Right? Transform dot rotation times this. Because otherwise it's assuming these are world coordinates as opposed to my local rotation. So let's try that again. It's one of my favorite mistakes to make because everyone makes that mistake and then they leave comments. I'm so confused. There we go. So I'm hitting forward. I'm hitting forward. 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 That all works. Left. Right. Backwards. Excellent. And I can fall off this and everything is awesome. Oh, God. Oh. All right. We do have perfect air movement right now, which that's a big question mark. Do you want air movement? Some people like that, and some people don't. Some people don't want air control, and again, it very much depends on what kind of game you're doing. On your character controller, there's a test called is grounded. There we go. If is grounded, then apply this. Well, that's not quite accurate because if it's not grounded, you still want to apply the gravity thing. With simple move, you sort of just have to do it this way. When we start using move, which we will incorporate as soon as we've got our jump. Oh shoot, let's just do it now. What the hell? This video is going to be a little too long. No, never mind. I'm going to put in a cut. Everything should be working fine. It responds to gravity, but we do have the ability to air jump or to move in the air. Or can we? Thought we could. Actually, don't know if we did have air control there. It's possible that simple move does not use your X and Z while you're in the air. We're going to look at that next video and have proper air control and the choice of whether you want air control or not and the ability to jump. But there we go, the running. And we're going to have it be so that our guy doesn't run nonstop. See you next time, folks. Bye-bye.